All right, so we have been discussing integers, and now it is time to move on to rational numbers. And the first thing we're going to do with rational numbers is write decimals as fractions and fractions as decimals. However, I need to discuss with you what in the world is a rational number. Can you close that door, please? She is so loud.
YouTube can hear you.
So a rational number, I'm going to give you my definition, and then I'll explain to you what that means in a second, because it might not make sense at first. So a rational number, in my terms, is any number that can be written x over y, where y is not 0. In other words, you know what maybe we should do? I don't like using x and y, because remember, y always goes in the numerator. So let's do this. Let's change it to a and b. Yeah, I know, I'm sorry. So any number that can be written a over b, where b is not 0. Rational number. What's the prefix of the word rational? And don't say rat. Ratio. And how can we write ratios? We can say 4 to 5. We can say 4 colon 5. Or we could write 4 to 5. 4/5 is a fraction. It doesn't have 0 in the denominator. Therefore, it is a rational number. Negative 2.3 is a rational number. 1 4/11 is a rational number. 0 over 4. We can have 0 in the numerator. We just cannot have 0 in the denominator. This is not a rational number. What's 0 divided by 4? What's negative 12 divided by 0? It's not 0. It's not 1. It's not 12 or negative 12. It's undefined. Undefined just means you can't do it. You can't do it. Let me show you in a real life example why this takes place. So let's use 4 divided by 0. What 4 divided by 0 means is this. Mr. Meeks gives $4 to 0 people. How can I do that? How can I give $4 to the person standing in front of the board right now? Who's standing in front of the board? No one. So how can I physically give no one $4? What would happen if I walked up to the board and gave that person $4? It would just fall down to the ground because there's nobody there to take the money. It can't happen. Well, we know that, Zeloff. It will not occur. It cannot occur. It cannot happen. There's nobody there. Now, 0 divided by 4 means Mr. Meeks gives $0 to 4 people. Which means I'm going to take my $0 and I'm going to give that $0 to Katie, Liv, Alex, and Hannah. You're welcome. I'm going to give each one of you girls $0. So how much money does each girl get? So that's why here we would get $0. In this example here, Mr. Meeks gives $4 to 0 people. It can't happen. Can't happen. So that would be a real-world example of how you would see 4 divided by 0 and 0 divided by 4. I can't give 0 people $4. However, I can give 4 people no money. I could give all of you in here, all 26 of you, $0. You're welcome. Hey, it's Monday, I'm just feeling generous.
Thank you.
If that doesn't make sense to some people, because some people, this example really, it doesn't click, let me show you mathematically. I guess I don't need this. Four goes into 0 how many times? What's 0 times 4? 0 divided by 4, which is right here, is 0. What number, when we multiply it by 4, do we get 0? What number, when I multiply it by 4, do I get 0? 0. Now let's take a look at the other one. How many times does 0 go into 4? In other words, what number, when you multiply it by 0, do you get 4? Oh, 0 times 0 is 4? Okay, well my question is, like this one, what number, when you multiply it by 4, do you get 0? 0. 0 times 4 is 0. What number, when I multiply it by 0, do I get 4? 1 times 0, 4. Is 2 times 0, 4. What digit, when I multiply it by 0, do I get 4? There's one number, right? Cam? Undefined. Or you could put a 0 with a line through it, which means undefined. It does not exist. There is no number that when you take 0 and multiply it by a number, will you get 4. This does not exist at all. There is nothing I can put in place of X to make that statement true. Nothing. Nothing at all. So we say undefined. Can't happen. Can't take place. Sorry. So do you guys know the difference now between these two? This is why this is not a rational number. This isn't a number at all. Doesn't exist. All right, let's take a look. Mrs. Budziak would be very proud of me right now. She's like the queen of Venn diagrams. So I'm going to make a little diagram of my own. Let's see here. Yeah, I know. So let's go with rational numbers. A rational number would be negative 1.2 that repeats. Negative 3/4. 3.5. 5.8. Those are all rational numbers. Underneath the rational number umbrella, we have what are called integers. You guys remember those? We just took a test on them. You should. Integers would be negative 10 and, let's say negative 2. Those are two examples of integers. Integers is underneath the rational number umbrella. Also underneath the rational number umbrella and underneath the integer umbrella, we have whole numbers. A whole number would be 0 or 4. Whole numbers, obviously, are whole numbers. So 0 and 4 is a whole number. 0 and 4 is an integer. 0 and 4 is a rational number. Negative 10 and negative 2 are integers. Negative 10 and negative 2 are rational numbers. Are negative 10 and negative 2 whole numbers? No. A whole number has to be positive. And then you have the rational numbers. The other word, the inverse of a rational number, is an irrational number. An irrational number would be pi. Square root is 7. Irrational number would be 5.2187369538271142368867420904. There's no pattern. No pattern at all. So what determines a rational number? A number that terminates, or a number that repeats. A terminating fraction, or a terminating decimal, (12 divided by negative 3). The answer is negative 4. That number terminates. Terminates means stop. It stops. The answer is negative 4. That's it. Three-fourths is 0.75. That decimal stops. Therefore, it's a rational number. 7/8 is 0.875. That decimal stops. It terminates. Therefore, it's a rational number. When we talk about repeats, 2/3. 0.6666666666666666666666666. Goes on forever and ever. Never stops. That's a repeating decimal. Repeating decimals are rational numbers. Negative 1/3. 0.333333333333333333333333, and it never stops. .4 with a line over it. 0.4444444444444. Negative 6.2323232323232323232323232323. That's a repeating decimal. Therefore, it's rational. Irrational numbers do not terminate. Irrational numbers do not repeat. That's why pi is an irrational number. Pi does not terminate. It goes on forever. It also never repeats. All of the numbers that are the value of pi are different. There's no pattern. It's just random numbers. The same thing with the square root of 7. So there's pi. The answer is 3.1415926541237. And it keeps going on like that. There's no pattern. Therefore, we call those numbers irrational. Square root of 7. 2.645751311124, and it keeps going on. That's called an irrational number. The square root of, I don't know if you've ever heard that number before. 1738. So the answer is 41.68932717. There's no pattern. It's irrational. Even if I took the cube root of 1738. The cube root's 12.02310364. There's no pattern. It's irrational. Now, if I did the cube root of 125, then that answer is going to be rational because it terminates. If I do the square root of 81, that's a rational number because it terminates. If we do 16 divided by negative 5, it terminates. Therefore, it's a rational number. 11/13. Look at the pattern. 846153, 846153, 846153, 846153, 846153. That repeats. It's rational. And you might say, well, Mr. Meeks, there's a 2 there. Well, the calculator has to round. If it didn't round, it would do this. And the calculator would never stop. You wouldn't be able to do any more functions. It would just keep doing this. But because the calculator only goes 10 numerals, 10 digits, it's gonna round at the end. That would be a 2. So, a rational number terminates or repeats. That's why this whole numbers are rational, integers are rational, they terminate. Irrational numbers do not terminate and do not repeat. So what we're going to be looking at this week is converting fractions to decimals. And now there's 2 ways to go about this. You can take this mixed number, turn it into an improper fraction, and then use long division. And then you can divide. If you did not want to turn that into an improper fraction, you could have left this as 2 1/4. And just done this. And got negative 2.25. So whether you want to turn this into a mixed number or if you just want to leave the fraction as is, you're more than welcome to do that. And you guys know by now, I don't care how you get the right answer. As long as you can show me it, I don't care how you got it. Whether it's my way, your way, some alien's way, mom or dad's way, it doesn't really matter. Now, these repeating decimals, I will tell you right off the bat, this one's going to repeat. So we need to do 11. Goes into 5. So 11 goes into 5 0 times. 11 goes into 50 4 times. Add another 0. 11 goes into 60 5 times. Add another 0. 11 goes into 50 4 times. Now, do you kind of see where our pattern's going to go? What do you think this next number is going to be? A 5. And then a 4. And then a... So 4, 5, 4, 5, 4, 5. You can stop right here. You don't have to keep going. You know that this answer is going to be negative 0.45 with a line over the 4, 5. These are not difficult problems. I will tell you the number one mistake that people make is they forget to put this negative sign with their answer. And then they get the darn thing wrong. They do a great job using long division. They reduce. They do this. They do that. And then they go to write their answer and they forget the dumb negative sign. Don't forget your negative sign or it's wrong. All right, I have 2 problems I want you to practice right now. Just 2. Not a big deal. Negative 3/11 and 1 5/27. Eric, what did you get for negative 3/11? Negative what? No, I have to disagree with that. Leah? That would be the correct answer. So we put 11 outside the bracket. We put 3 inside the bracket. 11 goes into 30 twice. Add a, whoop, that's not smart. Add a 0. Then we get 7. Add another 0. Add a 2. And then you can see that our answer is going to be negative 0.27 with a line over it. And what about 1 and 5/27? Ethan?
148 10,000ths with the line going over it.
Excuse me?
I got 148 10,000.
Ugh. I have to disagree with that one. Sydney?
I got 5.4.
5.4. We're in trouble. We don't know how to divide. You guys don't know how to divide. We're in trouble. Joe?
I got 1.185 with the line over.
Very good. 1. Not 5 point anything. The whole number out here is a 1. So you can only have 1 point something. So you take the 27. $27 goes into 50 once. Add a 0. 27 goes into 230 8 times. Add another 0. 27 goes into 140 5 times. And then we're right back to 50, so we get a 1. So the answer would be a positive 1.185 with a line over it. Bless you. The second part of this is converting decimals to fractions. And how would you say this number as a big boy or a big girl, Marissa? Right. How would you say that as a big girl? Because you're not going to say 0.26. You'd say negative. Very good. Negative 26 hundredths. And can we reduce this? Or no? London? Can we reduce this? No? Why not? Alex, can we reduce this?
Yeah.
By what?
Number?
What number? 5, 8, 13, 17, 38. Katie? Yeah, we can reduce it by 2. Both numbers are even numbers. What's negative 26 divided by 2? See how knowing integers helps? This is going back to division of integers. Negative 26 divided by 2. You just took a test on that. 100 divided by 2. So there's your answer. What about negative 0.7? How would you say that number as a big boy or as a big girl, Liam? Right, so we would say negative 7/10. Aiden, can we reduce that?
No.
Why not?
Because no same number goes in both of them.
Very good. There's not the same number that goes into both of those. Excellent. How would you say that number as a big boy or as a big girl? Gunner? Very good. Can we reduce that, Adriana? By what? Oh. Leah? 25s. 75s. You might all be correct. But let's do 5s. See what happens. Now, how do you know 5? They both have a 5 and a 0. So you know they're divisible by 5. So then we divide these and we get 25 over 200. Bless you. Can we reduce this again or no? Yeah? You can reduce twice? Oh, okay. And what would we reduce these by? 5. Very good. So we get 5 over 40. So now we're done because we reduced twice. You can't reduce 3 times, can you? Yes? You can reduce 3 times in a row? And what would we reduce these by? Holy cow. I didn't know you could reduce 3 times in a row. I thought 1 and you're done. All right, so we get the answer of 1/8. Can I reduce that? No. So yes, we could have divided by 25, like Leah said, or you could have divided by, I believe, 125. Yeah. You could have divided both of these by 125, and you would have gotten 1/8. All right. The only 2 problems I want you to practice are these. There's your homework. A whopping 2 problems.